Hello and welcome to our SOL review of A.02c, Factoring. Review of A.02c, Factoring. Now, the definition of factoring is finding what to multiply to get an expression. So you're kind of breaking something down into the parts that you multiply. And there's kind of two ways we deal with this. There's factoring of terms, and then there's factoring to create two binomials. So let's start with what I think is the easier one. So factoring of terms, you're just looking to see what can you multiply into both numbers, or you can even kind of flip it around. What can you divide both numbers by? So for instance, when I look here, 15 and 35, I happen to see they're both multiples of 5. So I can actually factor out a 5. So 15 divided by 5, that's going to leave a 3 behind. And we'll still have the other parts with the variables for now. And then 35 divided by 5, I can factor out that 5, and that's going to leave me with 7. Now, this is factoring because, as it mentioned in the definition with multiplication, 5 times 3 is 15, 5 times 7 is 35. So we factored out a 5 from both numbers. You can even do this with variables. So I've got an x to the 4th and an x to the 5th. I can take away 4 x's from both. So x to the 4th, that's actually going to take all the x's from here. So we're just left with this. And over here, we're going to be just left with 7x and then y squared. And we can even factor out a y from both. So it looks like y cubed, y squared. I can take out 2y, so x to the 4th. You can only take out as many as all the terms have. I know that this has extra y's, but since the other term only has y squared, that's all I can take out. So we're going to be left with 3y minus 7x. And that is factored. And if you want, a really easy way to just check is multiply it back out. You can distribute. We talked about that in 8.2b with polynomials. Now, the other way we use factoring is to factor quadratic equations. And quadratic equations are anything that goes ax squared plus bx plus c, and usually it has an equals 0 at the end. Now, as you can tell, 1, 3, and 2, they don't have any common factors, so I can't factor anything out of the numbers. And then x squared, x, and, well, it doesn't even have an x, so I can't take x out of everything. So using the method we just used isn't our best bet. So what's going to happen with this is you're going to end up with two binomials. So I'm going to go ahead and write them in right now. And again, if you want, you can always check this stuff to see, hey, does it multiply? Now what we're going to do is find the factors of 2. Now, 2 is pretty easy to find the factors of because it's prime, so it's just 1 and 2. So we're going to go ahead and put a 1 there and a 2 there, and you'll see why we're doing this in a second. Now, they need to multiply to make a positive 2, so they're either both positive or both negative. Well, in other words, to get positive 3, they wouldn't both be negative, so they're positive. Now, let's go ahead and check, and it might make a little more sense how I came up with these numbers and what I exactly did. So I'm going to go ahead and distribute. So I'm going to multiply that to that and that to that. So we're going to do x times x, which is x squared, and I'm going to do x times 2, which is 2x. Then I'm going to go ahead and do, whoops, sorry, got a little excited, 1 times x, and then 1 times 2. 1 times x is just 1x, and this is the one time I'm actually going to write it like that. And 1 times 2 is 2. Now, when we multiplied the two numbers, we got the 2. But when we add the two numbers, we need to get the middle term. So if you notice, I ended up with 2x and 1x, and 2 plus 1 is 3. So just by checking our work, I was able to get the original problem, so it worked out. So that's a nice, easy way to check. What's pretty crazy is you can actually combine both methods at the same time. Take a look at this quick sample problem I drew up real quick. So we've got 3x squared minus 12x plus 9. You always want to look to see if there's something you can take out before you have to do kind of the binomial factoring. If you look, not everything has an x, so no variable, so you can't do that. But 3, negative 12, and 9, those are all factors of 3. So 3 would be a factor. So we're left with x squared, negative 12 divided by 3 is negative 4x, and then divide that would be positive 3. Now, this 3 is still a factor. It's not a solution or x-intercept or 0 or root, which we'll talk more about in 8.4c, but it's still a factor because you factored it out of the polynomial. All right, so we know that we're going to end up with two binomials here, so x and x like that, all right. And we need the factors of 3. Well, again, 3 is prime, so that's pretty easy. It's going to be the numbers 1 and the number 3. Now look here. They need to multiply to positive 3. So they're either both positive or both negative. But they need to add up to negative 4. Well, the only way you can make them add up to negative 4 is if they're both negative, just like that. Let's take a look at an SOL problem. Which of the following binomials is a factor of x squared minus x minus 6? All right, you can't take any x's out and you can't take any numbers out, so we're going to go ahead and just start trying to break it down into the 2 binomials. All right, factors of 6. So there's 2 sets of factors. There's 1 and 6, and then there's actually 2 and 3. So we need to think to ourselves, what's going to multiply to negative 6 but add to negative 1? Well, no matter how you slice or dice 1 and 6, it's either going to be a 7 or a 5. It's not what we're looking for, so it's not those. So the answer has to be a 2 and a 3. And since it has to multiply to a negative, one of these is positive and the other one is negative. Here's how you kind of figure it out. The middle term is negative, meaning when I add these 2 together, I better end up with a negative. So that means the bigger number currently is going to become negative. And again, since they have to multiply to a negative, that guy's negative, this becomes positive. So there's our answer. And looking over here, the correct answer would be C. But I want to reinforce this real quick. It's very easy to check just by distributing. So here we go. X times x, well, that's x squared. X times negative 3 is negative 3x. Now we're going to do the 2. So 2 times x is positive 2x, and 2 times negative 3 is negative 6. I can put together these 2 terms, x squared minus x minus 6. It's important you check to make sure your 2 binomials multiply out to the original polynomial. You wouldn't want to make a mistake. Good luck.